pencils, scrap paper, and a triangle, as well as a homemade T-square and a little drawing board. We're not going to use the triangle today or the scrap paper, so you can set that aside. And then you want to either tape or clip your paper, your drawing board, and why don't you make sure that the paper is square to the T-square, which means that if you slide the T-square up and down your preferred edge, when it lands at the bottom, it is flush with the edge of the paper like that. Notice that this board is not perfectly square, and that might be the case with some of the boards that I made for you. So you have to clip your paper on a little bit crooked to make this work. Now the first step is going to be to use this ruler section of the T-square to mark up the bottom margin of your paper like this. So mark at every inch along the very bottom edge of the paper until you run out of numbers, which is going to be at 14. And then you're just going to slide your ruler over and make a few more marks like that, which should bring you to the end of the sheet. This paper must be slightly smaller than 18 inches. So this unit here is going to be a little smaller than the other ones, but we're just going to go with that. Next, you're going to find the horizon line, and we're going to measure that to be 8 inches from the bottom edge of the paper, like that, 8 inches straight up. And then we're going to use the T-square to draw a horizontal and because it's not quite long enough, I'm going to have to extend my edge extend it as best I can like that. Now we're going to find the middle of this horizon, which should be about 9 inches over, and we're going to mark what's called a vanishing point. You don't need to write this down, but and if you remember anything about 1-point perspective from middle school, it's that all the so-called orthogonals are the lines that go to the vanishing point. And we're going to begin creating those next. So turn your T-square upside down. Put your pencil in the bottom corner of your paper and swing that straight edge along so that it's going right to your vanishing point. And then pull a very light line from the vanishing point to the left-hand bottom corner, like that. The line should be very faint because we're going to be making lines. We're going to be doing our drawings on top of these orthogonals, and we're going to have to erase a lot of them, so we don't want them to be any darker than they have to be. Notice I'm aiming for the bottom of each one of these little marks. If I can zoom in for a second, you can see what I'm talking about. We're not aiming for the top of the mark, we're aiming for the bottom of the mark right here, where the mark leaves the paper. Obviously, since you're watching this on YouTube, you can fast forward through the boring parts as necessary, or I guess I could just pause and draw a few. See, those just appeared, didn't they? That's about the extent of the fancy video production that you can expect on this video. Okay, so that's our grid so far. We have 18 units along the bottom, all going to the vanishing point in the center of the horizon line. Now we want to add some more units, and in order to do that, we're going to have to make another horizontal. Because if we just started making units along the edge of the paper like this, and drawing to them, we would have only room for 8 more units. And obviously, there would be a lot more than 8 units visible on here. So what we need to do instead is think of this as a triangle and find the height of the triangle, which we already know is 8. And we go to the middle of that, which will be 4. So there's 4. And the middle is right there. Now we're just going to make another horizontal. I have to remember to always put the head of my T-square on the same edge of the board, because I know my board's a little wonky, so I have to just always go on that same edge. If I use the other edge, it's not going to come out. Doesn't matter if you use the left or the right, but just be consistent. And that was a little messy. Excuse me while I fix that. Notice if I want to be exact, I put my pencil point down where I want it first and then put the ruler up. That was slightly better. Okay, so I want you to think now about what we're looking at. Basically, we have horizon, and we've created a triangle. Then we cut the triangle in half this way. And notice that the proportions of this triangle here, which I'll shade, are exactly the same as the proportions of the big triangle that we cut out of. So these are similar triangles in geometric terms. So if we take two similar triangles and we divide the height in half, see the height of this is half of the height of this, then we know that the base is also going to be half the size of this base. And since this base was 18 inches, we know that this base is 9 inches. And that's important because it makes it very easy for us to determine the size of units along this line. There's still 18 units, but now they're packed into 9 inches. So that means units up here are no longer 1 inch like they were down here. They are now a ½ inch. And with that knowledge, we can easily add more units. So what I'm going to do is put any unit of my ruler here. Actually, probably make more sense to use my triangle. There it is. And put the 0 right here. And I'm going to mark by 1/2 inches going this way. And I'm going to go to the other end, do the same thing. I'll put the end of these, the number 5 right here, and I'm going to go by 1/2 inches this way. And you'll notice if we check that the units between these two are also 1/2 inches, or very close to it. So now we can use these little marks and we can add even more units to our grid, more orthogonals. And again, I'm not going to make you watch me do all this. And now we're going to go do the same thing on the other side. Please remember not to make your lines dark. And if you're in the habit of drawing everything dark, remember to get the tension out of your hand. Make a fist if you have to. Shake the tension out. You can only make dark lines if you are clenching your pencil tightly. If you're keeping your grip very loose on the pencil, your lines are going to be nice and light. So now we have 18 units across the bottom. We've got 36 units across here. And we could, of course, divide this in half again. We'd go up another 2 inches, make a horizontal, and up here our units would be 1/4 of an inch. And we could do that again where they are 1/8 of an inch. But that would take a really long time, and we don't really need to make a grid that is that expansive, so we're going to stop here. Now the next step in our grid is to make the rest of the horizontals. And I want you to think about this for a second. Some people think the horizontals should be 1 inch apart. So we could just go by inches like this and make 8 horizontals like that. In which case, the problem with dividing it up that way, though, is that we would end up with exactly 8 inches between our own position and the horizon. And as you've probably guessed, the horizon is not 8 inches away. It's much further away than that. In fact, since this is a geometric horizon, not a physical horizon, the horizon is actually about infinity away, not 8. In other words, there is no point in space where all of these orthogonals actually meet, and so it's just really, really far away for our purposes. And to get it that far away, each horizontal that we draw has to be a little closer to the next one than the one before it was. There's probably some sort of algorithm that could be used to establish that sequence, but I don't know what it is, and I don't suppose that you would be interested in learning it either. So we're going to use a little trick that artists have been using since the Renaissance for creating the horizontals, and that is the use of a diagonal. What we're going to do is exploit the properties, one of the main properties of any grid, which is that on any grid, if you draw a diagonal through any two corners on that grid, that diagonal is going to extend through a whole series of other corners for as long as you want to draw it. And this property holds true whether we're looking straight down on the grid or whether we're seeing the grid in perspective like that. So, if we create a diagonal, notice my t-square is upside down again. This pencil is in the corner, and I'm going to go through this point. This is the intersection between this horizontal line and this first orthogonal that we drew all the way to this corner. Right there. And I'm going to draw a very faint diagonal. Like that, and then I'm just going to cheat it out just a little bit further. Like that. Okay. Now, if you recall what we just saw, the principle of the diagonal is that where this diagonal intersects an orthogonal, these are the orthogonals, it's going to locate for us each of our horizontals. And that's what the t-square is for. We're going to hold the t-square along that edge and draw orthogonals like this. Oops, I kind of missed that one. Okay, that should have been right there. Sadly, these t-squares are not quite long enough to take us all the way to the end of our lines, which, as you'll notice, I'm attempting to make very faint. If you have a better T-square at home, feel free to use it. And if a couple of your lines are a little bit off, don't stress about it. Most important thing is that they're faint and parallel. So I'm going to skip that one, which I already made. And notice that as we go up, they're getting closer and closer together. In fact, if we did attempt to go all the way to the horizon, we would end up basically just shading in the top inch or so. The lines would be so close together that there would be no visible space between them. So we're going to stop when we get to the last orthogonal there. And then I'm just going to go back and add to the lines to complete the grid. Just trying to line up with the ones I did. Notice I'm not trying to use the head of the T-square now because my board is not perfectly square. So this is actually going to be more accurate. So what we've just created is a one-point perspective grid, similar to the grids that were developed in the Italian Renaissance, late 1400s, early 1500s. And we're going to be drawing on it in the next class. First, though, I just want to explain one more thing about what you're seeing here. I chose this angle to ensure that these boxes on my grid would be foreshortened. That means that they are shorter in this direction than they are in this direction. And you may be wondering why they should be shorter. After all, this thing is supposed to represent a square, and squares are equal height and width. This is obviously not equal height and width. Notice, though, that if we take any of the squares on a grid, it only appears equal height and width if we're looking straight down on it. If we tilt the plane away from us like this, what happens is these edges, which are running perpendicular to our line of sight, 90 degrees to our line of sight, which you can imagine going this way, these don't get any smaller, but the ones that are parallel to the line of sight do get smaller. Now it's really hard to see them as smaller, which is why most beginners draw foreshortened squares like this, much more like real squares. They don't foreshorten them enough. That's because when we see a foreshortened form, our brains are very well adapted to interpreting it as foreshortened. In other words, we still see this as a square, not as a rectangle, because we know unconsciously, our brains know what we're looking at. We know it's still a square no matter how we turn it, no matter what angle we look at it from. Your brain still says that's a square, and so you want to draw it like this. What we're trying to learn how to do is draw things that appear to be squares the way they actually appear in our visual field, which might be something like that. The basic principle of foreshortening is really simple. Basically, if you imagine yourself from above looking forward, here's your line of sight. Here's your visual field. This is what you can see without moving your head. Here are your shoulders. And if a form is perpendicular to your line of sight, like let's imagine this is a pencil, it's going to take up more room in your visual field than the same form would if it was parallel to your line of sight. If this same pencil is turned this way, it now occupies a really small area of your visual field. Whereas the same pencil turned the other way occupies much more. And we can demonstrate that with an actual pencil. If I turn it like coming right towards you, occupies very little room. If I turn it like that, it occupies much more room, and if I gradually change the angle, you can see it occupying less and less space in your visual field. Again, our brains are incredibly well adapted to perceiving foreshortened objects, so we don't look at the pencil and say, oh my God, how is he making it shrink? We interpret it as, well, he's just turning it towards us. But we find, because we see it still as a full-size pencil, we find it very hard to draw it as short as it actually is right now. Because the proportions of this pencil, when it's turned towards us like this, are not the proportions that we think of as being pencil-like. So keep that in mind as we go forward. The word foreshortening is going to come into our conversations more and more often. So that's it for today. Make sure your grid is ready to work on for the next class, and we're going to start populating it with some of the shapes that are already familiar to you from before. Thank you.